be looking at the next function, right? For this function, f of t is given as sin at. So far, we derived or we found the Laplace transform of 5 functions so far. Sorry, of 4 functions, which are when f of t is equals to a, when f of t is equals to exponential negative at, when f of t is equals to sin at, and when f of t is equals to cos at. So we want to find the other functions, the possible function we can be given or we might be seeing later on. The way Laplace works, I said it in the introductory class, saying it's just like differentiation and integration. For our differentiation, I have different techniques. To solve my given question. I have product rule, I have quotient rule, I have chain rule, right? So similarly, Laplace transform also has its theorem, meaning the techniques to implement. So we call it theorem. So there are just 3 theorems basically. We have the multiplying by the exponential function, dividing by the t function, and multiplying by t raised to the power of n. So we are going to see all of these theorems later on, right? So let's fill up our table. Let's finish up with our Laplace standard table. Now from here, the same way we did the previous transformation, just that you are going in a ascending order, meaning you are implementing the idea of the previous transformation to the next transformation, right? Now from here, we want to transform sin 80. We've written it out, saying the Laplace transform of sin 80 becomes what? Integral from 0 to infinity sin 80 multiplied by exponential negative s dt. Now, we've seen the concept that when solving some integral function in Laplace transform, it is easier when we do some manipulation, saying expressing the trigonometric function as exponential function so as to perform indices, then integrate. So that's what we are also doing here. I'm having sin 80. The question now is, can I solve this integral function using my part? Yes, I should be able to solve it, but it's going to take a lot of time, a lot of processes. So I'm not saying there's a relationship or there is this connection between sin 80 and exponential. So we are recalling. So recall or note that sin 80 is equals to 1 over 2 all into bracket exponential 80 minus exponential negative 80. So what it means is that anywhere I see sin 80, I'm substituting the whole of this. By the time I substitute the whole of this, I do my multiplication. After multiplying, then I integrate. So that's the concept. Now from here, solving that, meaning I have integral from 0 to infinity, replacing this, say this is 1. Substituting 1 into your Laplace formula, it becomes 1 over 2 all into bracket exponential 80 minus exponential negative 80 multiplying exponential negative st dt. From here, I can factor out 1 over 2. 1 over 2 is a constant, applying the idea of integration. So I'm having 1 over 2 integral exponential 80 minus exponential negative 80 multiplying exponential negative s dt. Alright, now open your bracket, meaning multiply this by this, meaning multiply this exponential with this bracket. It becomes 1 over 2 integral exponential 80 multiplying exponential negative st, right? Negative, okay, let's open a big bracket, saying I have a big bracket, this multiplying this, I have exponential, introduce your upper and lower limit. I have exponential 80 multiplying exponential negative st, right, minus all into bracket exponential negative 80 exponential negative 80 multiplying exponential negative st. Close this bracket. we have what? The t. All right. Now from here, let's simplify this. Or what we just did here, what we've done so far, what we just did here, we expanded this bracket, saying factor out your 1 over 2, then use this function to multiply all three. So you have this. You have this. Now from here, let's integrate. But before integrating, let's write this function, this integral function in nicer way, meaning summing the power of this exponential, also summing the power of this exponential. So by doing that, I have 1 over 2 integral 0 to infinity, all into bracket. This becomes exponential negative x minus 80, right? Minus exponential negative all into bracket x plus a. You then have this. From here, what do we have? We then have, after taking the power of these two exponential, it becomes this, right? You have this and you have this. Now up to this level, let's integrate. All right, we're integrating. It becomes 1 over 2 all into bracket. Integrate this, meaning exponential negative x minus 80 all divided by negative x minus a minus exponential always to the power of negative x plus a multiplying t all divided by negative x plus a. Close your bracket. Introducing your lower and upper limit. Your lower limit 0, your upper limit infinity. Alright, from here let's substitute our lower and upper limit. But before substituting our lower and upper limit, I can write this expression as 1 over 2 all into bracket exponential negative x minus a all divided by negative x minus a plus negative times negative, it becomes plus exponential negative x plus a multiplying t divided by negative x plus a. Introduce your limit from 0 to infinity. Now, how your limit works is that your upper limit is taking the whole expression, then your lower limit is taking the whole expression. So by doing that, we then have 1 over 2 all into bracket 1 over 2 all into bracket exponential negative infinity all divided by negative all into bracket x minus a plus exponential negative infinity all divided by this minus all into bracket exponential always to the power of 0 all divided by negative all into bracket x minus a plus this all divided by x plus a. So what I just did here, you see the same thing we've been doing when we did you see the same thing we've done so far when we did the transform of sine 80 and cos 80. Now substituting my lower and upper limit, my upper limit which is infinity, you know, your lower and upper limit, you are representing it or you are substituting it as t, meaning for this first bracket saying exponential negative infinity all divided by negative all into bracket x minus a plus this. What you've done is that infinity multiplied by t, you have infinity, so you are saying exponential negative infinity divided by the denominator plus exponential negative infinity divided by the denominator, right? Minus, now take your lower limit which is 0, minus, same idea, in place of t substitute it as your lower limit. So 0 multiplying all this, you have exponential 0 multiplying all this, you have exponential 0. Now from here we know that exponential raised to the power of negative infinity becomes what? 0, meaning I have 1 over 2 all into bracket 0 plus 0, right, minus all into bracket 1 divided by negative x minus a plus 1 divided by negative x plus a. Alright, for this bracket I have 0 plus 0. For this very one I have 1 divided by negative all into bracket x minus a plus 1 divided by negative all into bracket x plus a. So let's simplify further. Let's simplify this. We simplifying this, I have 1 over 2 all into bracket 0 minus 0 plus 1 all divided by x minus a minus 1 all divided by x plus a. Using this negative to open this bracket, this is what you have. Meaning I'm having 1 over 2 all into bracket 1 over x minus a minus 1 over what? X plus a. Alright, now from here, let's do our LCM. Doing your LCM, this is what? You do your LCM, what do you have? This is difference of 2 square, right? This is the difference of 2 square. Meaning, we are saying that negative a all into bracket x plus a. This multiply this, what do you have? S square plus ax minus ax minus a square. This cancel out. You are left with what? X square minus a square. So that's it. That's it. Meaning from here, I'm having 1 over 2 all into bracket x minus a open bracket x plus a. This divide this, I'm having x plus a times in this. What do I have? X plus a minus x minus a. I then have 1 over 2 all into bracket x plus a minus x plus a, right? Then this gives us what? X squared minus a squared. We've seen earlier. This cancel out. This cancel out, right? It then becomes 1 over 2 all into bracket 2a over x squared minus a squared. 2 cancel out. You are left with what? A over x squared minus a squared. Therefore, the Laplace transform of sin 80 is equals to a all divided by s squared minus a squared. So back to your table, right? The Laplace transform of sin 80 becomes a all divided by s squared minus a squared. So that's how it works. That's how it works. Meaning that given a function sin 80, the Laplace transform becomes what? A all divided by s squared minus a squared, right? So this is what we are saying. You know, I said it the other time, saying that the trigonometric function says sin 80 and sin 80. They are Laplace transform. They are synonymous. The difference is the denominator. The difference is the denominator. Now, from here we said this is sin 80. The denominator becomes what? S squared plus a squared. But for sin 80, what am I having? S squared minus a squared. So meaning, no need of us cramming the transform. No need of us cramming the transform. Once you know sin 80, you can easily recall what sin 80. So similarly, without solving for cos 80, the Laplace transform becomes what? S all divided by x squared minus a squared, right? But you know, this two guy, which is sin 80 and cos 80, this is the expected way. What we've done so far, this is the normal way to go about it. But we have easier way in which you can find the Laplace transform of sin 80 and cos 80. So what I'm going to be doing, is that from here, the first one, which is sin 80, we found the Laplace transform using substituting it to our integral function, right? But we can also use the faster method. We can also use the faster method to solve it. But I'll be using that when solving for cos 80. Meaning, this what you'll be learning when it comes to cos 80, implement it to what we just finished doing now. You will definitely get the same answer. Similarly, what you've done now, implement it to cos 80, finding the Laplace. You will definitely get the answer we will be getting as well. So let's take the next function. Let's see how we can transform the next function, which is what? Cos 80. So let's see how we can transform cos 80.